Welcome back, guys. Today we're going to go through an example, hydrology example, showing a project that is using too much storage. In this one, we're using Hydragraphs Hdyroflow and arch chambers, I think specifically storm keeper units. And so the original design before we started this video just took up too much volume, and so I'm going to go through and check a number of things and figure out how we can reduce that storage volume down and run all the calculations back through the different spreadsheets and software that we use. So let's learn. Okay, so we're starting with Hdyroflow. We have a Hdyroflow that's here, and we have a basic system, but we're using way too much storage, so we want to figure out how we can get our storage down smaller. So we know our elevations. I'm going to grab a piece of text. And we'll make this green, shrink it down a little bit, and we're going to assume that our top is at 10. So that's going to be right there. This is going to be 2.5 feet down, 6 inches for the top and 2 feet for the cover, which is, where is it? 2 feet min from the top of this to the bottom of the section. So that's actually right there. Then we go down another 3.79 feet for the chamber, and then they have 9 inches. I'm just going to stick with the 9 inches since that's what they had on this, but typically that varies. Typically it's 1 foot. So 7.5 minus 3.79 is 3.71. We'll just say 3.7 because I don't like doing hundredths. And then 3.7 minus 0.75 is 2.95. I guess we will do hundredths there since that's halfway. Alright, so that's roughly where we think we might do this. In order to do that, we need to raise this guy up a little bit. We need to put some flumes in here. I don't want them getting near these metal brackets, so I'm just going to draw a line and go halfway in the middle. And then I'll do it 2 feet on either side. Does that look kind of dark? And so we have that one, and then we'll have one down here too. So that's probably where our flumes will be. So let's see, this slopes down in here and then comes back that way. This slopes down and comes that way. We basically have a swale here. This water goes this way and this water goes that way. But rather not be pointing water towards the building, this close to the building, when the water is already coming this way. Because basically what we're telling the water to do is to go like this and then come back here. And the water might as well just do that. So I'm going to recommend some other numbers. And where did the spots go? Huh. What happened to your spot elevations, the existing and proposed? Do you know?
No, I've just been seeing X's inside the blog for a minute.
Say that again?
Since it's, no, it's just been X's. I think that's the same across other drawings too.
Shouldn't be that way.
I don't remember any being there
Really?
in AMP. I was just using the Kogo points and then setting the style to propose an existing.
CAD tile block. There we go. I grabbed the wrong size. Alright, let's get out of there. Let's just check while we're here the project template. Maybe it somehow got deleted out of here. They look like they're there too. But that's weird. Someone deleted the 10 of the 20 out of there. Now they're all in the older one. All right. So this, you've got 2/10 over 18 feet. 0.2 divided by 18. It's 1%. That's good. Let's just keep this going down at 1% for another 25 feet. So we'll round that up to 3/10. So this will be 610.7. And let's make this, what color do we want to make it? Yellow? Does that stand out enough to know that they're an optional thing? We drop another 2/10, which would be 5. This curb line shouldn't stick out in front of this guy. I keep seeing this lately. I don't know where it came from, but it's already hard enough. You know, when you go into a parking lot, you got a little drive aisle, and then you have this little curb there, and you need to turn. There may be someone coming out, and you need to make a sharp turn to get in here, and you got this curb sticking out, and you know, you wish it wasn't there. What I like to do is draw them. This is ideal, but I never take the time to do this on a preliminary. If your parking spaces are like this, I like this guy's gutter line to be like that, and the curb to be like that. So when you look down this thing, visually, it's like a straight line all the way. If you actually do the face of curb out the same place as here, which is the way I draw all my preliminaries, the gutter actually sticks out. And so when you're driving and you're trying to make this corner, it physically looks like, you know, the gutter is sticking out past this, and you know, you got another car sitting here, and you're trying to squeeze in here, and you're like, man, why wouldn't they just give me like a couple extra feet? So if anything, you want to move this back 1.5 feet. So instead of the face of curb being there, the gutter's there. That's what you would do ideally. You know, we're all about speed for preliminary, so we usually just leave it that way. But in this case, it's actually sticking out further into the drive aisle, so it's going the wrong way of ideal. So we should update that. But if anything, think about pulling it back, not sticking it out more. And then what that does also is this guy that's bailing out and he's coming in, instead of coming in more towards the center of the driveway, you're putting him over on the side of the lane that, you know, where he should be. All right, So we kind of kept this at a minimum slope. One thing you can think about, if you need to get water from here to there, if you slope it in the two directions at the minimum slope, you know it can get this way because it can get the longer distance easy, you know, in the minimum slope. So now from here to there is 70 feet. So if we drop another 7/10, we are at 6.9.8. And then we need to get from here to there. That's going to be another 1/10. Seven. And then 6. Now you can see we didn't meet my goal of 10. We're short by 4/10. And let's see, let's just kind of review all this. 11.5, so we drop a 1/10 there, 4, and then 9 should be kind of 10.9, but we're at 10.2. This is actually going what are we doing here?
It slows down for the hatching when you get out of your van.
Did Shane have that? We agreed that he was going to put the door in here on all these projects. I think it's fine on this one because we have enough space, but some of them we don't have enough space. So let's look. Halco Architect. Okay, so we don't even have anything from him yet. Hey, Tim.
Hey, I've called in enough messages regarding the Mary Camp progress,
Yeah.
and just want to give you a heads up. I haven't heard back from anyone yet. I didn't know if we should respond back with those emails and say something. Or...
No, because I told him we're checking into it, and I gave him the info that we have. So
They just had on that email there was like an urgency for where to go. Anyway, they were saying that we needed to know something by today whether they wanted to submit something for this week, for tomorrow or next week.
yeah, okay. Well, then you can tell them we haven't heard back, I guess.
Okay.
All right. Thanks.
All right. Thanks.
So let's leave it. So this guy in front of the door would need to be the same as this, or if you're 2/10 down, you can't get up in there, right? So this guy should be 0.5, and then you typically slope 1/10 over the sidewalk. So that's going to take you down to 4 right there. And if you keep this perfectly flat, it's going to be 4 here, and then it's going to slope down to 10.9. Now, you could also choose to just start sloping down at 5%. Anything less than 5% is ADA. If it's over 5%, it's considered a ramp. And any ramp over 6 inches tall has to have handrails. So if you're going to do a ramp, you might as well do the steepest ramp that you can, which is 1 inch per foot, or for a 6-inch curb, it's a 6-foot ramp. If you make a 7-inch tall and 7-foot long ramp, you need to have handrails for the whole thing. So, if you're going to make a ramp, you might as well just make it the steepest slope and either keep it to 6 inches or less so you don't have to have handrails, or at that point then drop down to 5%. Well, it also gets confusing. If you decided to go down at 5%, you basically would go down over the course of one parking space. You could slope down your 6 inches, But at that point, like, there's really no reason to do that when you can just do your normal ramp in 6 inches. You don't want to have like a low sloped ramp and have like this half of a curb, you know, that's tapering down over some long distance, because then it's hard to pour. You just want to do as much straight curb as you can do, and then do your ramp, and then pour everything flat. So this guy, we'll get rid of those. Keep that at 0.5 and 0.4. And did I accidentally delete that 4? Yeah. Delete these 2. Why are these things act funny? Delete. Delete. So that's going to be the same thing there. And then when you get here, it's going to go down your 6 inches. So this guy is going to be 0. And this guy is going to be 10.9. Which means your, is that a curve? Yeah, I'll just make that a straight line. And that's just going to stay in here in the curb until you get to the ramp. Make that a line. Let's go ahead and make this a line. So that's going to cut across this, because this is below 11 and that's above 11, and that's exactly 11, right? Does that make sense?
Yeah.
And we don't want any curves in there. Where's your curve line? There it is. Is that another curve? Oh, that's straight. Okay. Alright. This guy. And you really, there's no reason to have a ramp going up. Ramps are expensive. I've seen them priced out as much as $1,000 for just a handicap ramp. So why just add a $1,000 ad to have a ramp to go nowhere? So we can just keep all of this. So that's another thing. Whenever you hatch things, just hatch everything individually, because if you ever need to make changes, then you have to rehatch everything and not just the one thing that you did. So we need to rehatch this. I'm going to use this guy to take that and apply it there. Then we can go ahead and delete that. Then we can get rid of these guys. And then, so I'm going to lose, I'm going to change this to not associative. And I'm going to move him down here where we can't really see it instead of rehatching everything. Solve that problem. And then we get rid of that. And then this guy, we want to break. On this side, it's a hard line. Let's go back to the site plan so you can see there. It's actually, this is the one I meant to break. The face of curb. Here, there's no curb. So here, we need to just delete that. This side, I would make it cyan because it's really part of the sidewalk. This guy is part of that sidewalk too. It's really just a seam. You know, this is concrete and that's concrete, and they're both at the same elevation. It's really just a seam, kind of like we have out front there. And so that stops when you get to the ramp, because this isn't curb and gutter. This is just a custom thing that they have to make, right? So I like to take this guy and here make this a different color, because that's where it starts changing. from being a curb to something special. And then that shows your ramp is there. And then all of this is just flush. Alright, so we'll go back to the grading plan, and really all of this can stay the same. This guy is going to be 10.9, and then we need to slope down, so we need to lower everything a little more. We're going to change this one to 10.7. Promise we'll get to some other stuff. This one's going to go to 5. Everything's going down 0.2. 5. 10.3. Ten point 6, 5, 4. Okay, so we're at 9.4. So let's go back down to this guy, and we'll take 6/10 off of everything. 9.4, 6.9. 3.1, 9.35. Alright, so the bottom of our thing, these are the elevations. So what I was talking about yesterday, they may want us to give water quality because they probably typically see water quality, but we're in a weird situation that we're reducing our impervious area, so we technically shouldn't have to do any. But they may still say, well, you still should do something. Well, we have to have this stone here anyways for the chambers, so why don't we just put our hole here, and then we're giving them some anyways. Just take credit up, and then we'll put our hole right there. So our hole we'll put at 3.1. So we'll lower this guy down. So it was a weird number, but is it a really good weird number? 6.2. Let's leave it at 6.2. We'll have a little bit low cover there, but you could also say that this slopes 1/10 of a foot. You know, by the time we get here, we're up to 6.5, or sorry, 9.5. You know, by the time we get to the actual chamber. You know what I mean?
No.
This is 9.4.
Mm-hmm.
This has to be low. All of this has to be higher because it slopes that way, right?
Oh,
So this is going to be 9.5. Well, if it's flat, water's not done move.
Oh, the ground slopes, not the
Yeah.
not the tent. Okay.
Yeah. So if we were measuring 2.5 feet down, we could really come up 1/10 and measure 2.5 feet down, and therefore we just keep this, and then we don't have to change any of that.
Series
So again, we don't want to make this any deeper than we have to, so let's just do it at 1%. So this guy is going to be 21. We'll make him coming in at 3 and going out at 9. And from there to there is 45. We'll do 5/10. So it's going to come in at 2.4 and go out at 2.3. And then from there to there, 90. So 1.4. So we're going to come in at 1.4. But then we're going to go out 5 feet deeper so that we can get past this swale here without having our pipe come out of the ground. And now this is more shallow. Now another thing we need to think about is the geogrid. If we're doing a modular wall, they're going to have some geogrid coming in here. There won't be any here. Typically, the geogrid might be as deep as the wall is tall. So if we're down at 602 and the wall, what's the top of the wall?
It can be labeled on the side plan. Nope.
Top of grade, 602, let's say 611.5, and the bottom grade, you really want to kind of have like an even bottom. You don't want to have it going up and down. It just makes it harder for them to do. So this is kind of our tightest spot. Right there we are 3.3. So if we made this guy 601, wait, that's 602. If we made that at 602, whatever the last stuff. All right, 9 feet. That's not that bad. Oh man. So this being at 602 is at the bottom of our thing, isn't it?
Needs to be lower.
Not necessarily. So if it's 9 feet tall, you can imagine the geogrid might be, you're really not going to have any in the top few feet. But if this is 9, that probably is going to be about 9. And if we have a pipe there, we probably want to be about 9 feet away. And let's just offset 9 from this guy. So it'd be nice if we could move this over just a little bit. Here we're fine because it's out of that thing. But this guy, we can move down. I don't think it's really going to make that big of a difference because, it's still going to slope. So let's just move that guy a little bit. And I'll move it in the direction of this pipe so it doesn't, so you don't have to change much on your profiles. Like that.
It's okay, profiles are TB.
What is that? Okay.
TBD.
I'll just lower that 4 feet. And that gives us some space there. Alright, so now this guy is 61. We're going to make all these 24, and it's basically 1%. And now this guy, I think, was he 90? 91. 91, 24, at 1%. Alright, now we have a little more space here from that footing, which is kind of good. Okay. Alright, so we redid that, and so now let's think about our water quality. So the area of our thing is, the area of our bottom's 3160, right? We have 9 inches of gravel. So 0.75 feet of gravel times 0.4 is for each. I like to think of things in per unit volumes, especially with cross sections. So we have 0.3 cubic feet of storage for this per square foot of cross section, right? And our cross section was 3160 times 3160. So we have 948 cubic feet of water quality volume. Actually, nothing was soaking in, did it?
Infiltration.
Yeah.
Was like
Wasn't it
0.
like 0.03?
Yeah. Can we also factor in those end caps for would be rock under, because the area was drawn around.
Yeah, but we don't know what that is. I don't like calculating that volume. We let Southeast Culvert calculate that for us, but and the software can calculate it for you. But I have no idea what's in that three-dimensional curvilinear. You know, it's an arc in this direction, it's an arc in that direction, it's an arc. In three directions, it's an arc. I just don't want to. I don't even know how to do that. You know, I'm a big picture kind of guy, and so I like to make sure everything works from a big picture viewpoint. All right, so let's just call this. We might as well make this 6 inches then, because we're not. There's no 57 stone to soak in. It's just, it can just be crush and run, because nothing's going to soak in, right? So let's just make that 6 inches. So let's raise this up a little bit. And 6 inches below is 2.5. Alright, so then now if we want to do water quality, we can't say that's our water quality because it's never going to soak into the ground and it can't get out the hole. So it's basically, once it rains once, it's trapped forever, right? So why waste the money and buy clean wash 57 stone? You might as well just put crush and run in there, right? So we're going to do our water quality by just giving them a little hole for a small volume. And they said they wanted 1.1 inches, right?
Right.
1.1 inches divided by 12 to convert to feet is 0.09. And let's just say we gave them a quarter acre worth. You know, as though we were increasing our pervious acre for a quarter, but we're not. We're decreasing it. But we're just going to give them some anyways. Times 0.25 times 43,560 acres. That's 1,000. So that's about where we were. So let's just kind of keep in mind ball, park, water quality, 1,000 cubic feet, and that is 1.1 inch divided by 12 times a quarter acre times 43,560 acre square feet, no, square feet per acre equals 998. Okay, now we don't really need to do this, but we know that in our chart, calcs, pond design, is this just a random thing? Quarter acre. Water quality, 1.1 inch. So there's our 998, right? Do you have your pond in here? Is that from this?
Yeah.
Okay.
That's
And it's probably going to change a little bit, but oh, we don't have any.
yeah, because it was,
Oh,
since
you
we're using
just
underground, it had volume, so we had to go in and enter the
you just
volume
put the volume.
rather than, yeah.
That's fine. Right, that's different. Where do the chambers start? Let's look and see where the chambers start. We're gonna have to go back and iterate and change this because I think the pond's way too big. But there's no reason to like get this exact and then go back and change the pond and then put all the numbers back in there again. So I want to get just like a rough ballpark of this matching that, so that we can change it, so that we can get this roughly correct, and then we can go back and redo that all at once. So the bottoms, the inverts of the units are at 603.2. I can't type anything in. 603.2, and that's 0, and then we go up to 603, and that was 690. No, it's going to be 603.5, 694, and then the next one up, 604.11.
1284.
1284. That's more than enough. Where do these kind of strange things come from? Oh, it probably spit it out, didn't it?
Yeah.
It just divided it into 10 pieces.
That's the.
Okay.
The shape of the.
So there's our water quality volume, and it happens at 603. So it comes up 0.4 inches above the bottom. So now I'm just going to go back in here. Water quality orifice, 603.2 is the bottom, and it calculates it at that. I mean, that would just clog instantly. So we'll just do an inch. Since we don't have a real requirement anyways, and we want to give something that works. Alright, so now we know that we're going to do a 1-inch hole. Let's go in and start designing our pond. So we're not going to have, here's where you need to start paying attention again. We're going to have, we don't have any water quality requirement. We're doing a little bit anyways out of the goodwill of our hearts, but our only requirement is attenuation, right? So we want to let out as much water as we can let out, but not go more than it was previously, right? If we're holding back extra water, then we're just wasting volume in our pond, and our underground pond is really expensive to begin with, so why waste extra volume? So we just want to start letting out as much as we can from the very beginning, with the exception of our water quality volume, and we're not going to make that very big. So, for now, we're just going to leave this the same. And I like putting my outlet pipe a little bit lower than my holes. My holes are, what is this? This thing, where can we move this guy to? There we go. The bottom is at 603.2. So that's where our first hole will be, 603.2, because below that nothing can drain out. So we'll put this guy. Oh, that's what we said this pipe was draining out at, right? Yeah, 603.2. Let's make, we don't want to make that a little higher. We'll leave that the same. And we're going to make this a 1 inch, because that already is going to be thinking about clogging. And then our next hole, we'll just come in, I don't know, 3 inches above it. Oh no, we said, what did we say it was? How big? 0.4?
Yeah.
Pond design. Water quality elevation 603. Yeah, 0.4. So we'll just do a half a foot. So we'll come up 603.7. And the reason I did a half a foot is we typically come up an extra tenth over whatever this elevation is, just so the contractor could make it wrong and they don't, you know, encroach into that volume. So if we just go by that same principle, that makes it 603.7. But in reality, we don't have a requirement, so we could kind of go up or down anyways. But 6 inches is also just kind of a nice even number. You know, it's not that big. And then if you have a hole down here, it still is just a small gap in between. So let's put a 6-inch hole, and we'll see what happens. And so when you run these things, you always want to start, we're going to design from the bottom up. And we're going to, because once the water ponds up to a certain volume, everything below it is just going to stay exactly the same. You know, the water, you know, if the water fills up to here for a 1-year storm, we get the 1-year storm working, it's going to be the same exact discharge every time it fills up to that elevation. So once you know, we get this one dialed in, then we're going to go to this one, and we're never going to go back to that unless we change the pond shape, and then we got to start at 1 again and work all our way up. So so here's our pre and our post. So we have 5 times. We're restricting it 5 times more than we need to. There, still about 6 times. There, about 4 times. There, 2 times. There, 1.2 or so. All right, so we'll run it. All right, we let out a lot more, but we still could let out a lot more. So let's look. So let me show you this formula for water flowing through an orifice. Documentation, stormwater discharge through an opening. I drew this about 20 years ago. So there's the flow, Q, and the formula is the opening coefficient times the area times square root of 2GH. H is your head, but you can turn this thing sideways and it would be the head from the water to the center of the orifice. So, and then 8, and then G is gravity. So that's basically all it's doing. So we can let out more water by either increasing the head or making the hole bigger. Which means we could lower the hole, but we can't lower the hole because we already have it at the bottom. So we pretty much need to make it bigger. But you want to look at this and see how high it's ponding up, because that tells you how much head you have. I think we put that guy at 2.7, and so we have 2 feet of head. Our pond only goes up to 607 is where the last overflow is, so it's not very deep. So let's just make this sucker bigger. Man, how many trees are they taking out over there? All right, so we could still let out more. Let's lower that sucker a little bit and just get it a little bit closer to that guy. If we did 5, that basically would be like a 10th. Oh no, 6 is where the water quality elevation was. So we'll just go to there. All right, so we're still letting out, we're still holding back too much, but the only option is go to like an 18-inch hole or 2 12s or something. And before I make a decision like that, I do want to see where we are with these, because once you start putting a huge hole like that on the bottom, that's just really weird. We're probably going to be letting out too much at other elevations. So let's just kind of check and see where we are. So we're still good there. We're still good there. Still good there. Still good there. Still good there. And good there. So probably the reason we're not letting out too much water is because the pond is so shallow, we never generate enough head to really push a lot out through that 12-inch hole. But I guarantee you, if you had a 10-foot deep pond, it would just be gushing out of that 12-inch hole. But we don't have 10 feet ahead, we have 2 to 3. So let's try something else. And keep in mind, our outlet control box is only 4 feet wide. So we have an overflow and we have this we have this little 0.1 or 1 inch hole down there, and then we have a 12. We could do 2 12s, but that's probably all we could fit in this 4-foot space, you know? So let's try that and see what happens. Outlets, 12, 2 barrels. Alright, so we're a foot, 1.5 CFS shy. We're getting closer. We could still let out more. We could still let out more. Still let out more. Alright. So we're kind of even now. Before we used to be like really conservative on the lower storms and the closer on the high storms. Now we're kind of an even percentage reduction kind of across the storms. And look, in the old design, on the 1-year storm, we were ponding up 8,000 cubic feet. Now on the 100-year storm, we're only ponding up 6,000. And we still don't have it dialed in yet. I don't remember what the number was on the,
So did I
on
say
the 100.
we're lowering our pond volume by 2,000 cubic feet? Is that what that's saying?
Well, it was 8,000 on the 1-year storm. I don't even remember what it was for the 100. I guarantee it was a lot bigger than for the 100 than the 1.
Oh, 11 maybe.
Okay, so if it's 11, we've cut it by 45%, but we're gonna cut it more. Let's try. Can we fit 2 15s? 15 times 2 divided by 12. That's 2.5 feet divided by 3 spaces. 2 on either side and 1 in the middle. That's 10 inches, so we can still have 10 inches between the walls. That's fine. Let's try that 15. Is this making sense?
Yeah, we're increasing the size of the second, or just let out more water so that we don't have to store as much.
So see, that really didn't go up much because you just don't generate enough head to take advantage of this bigger hole. You know, okay, it is what it is. We're still letting out more. I mean, so we're still totally fine. And we're less than 6,000. All right, now here's something else you need to think about. When you make changes to the pond, you heard Michael say this, just change one thing at a time and see what it does. And you need it to make sense. If you change it and you think it's going to go down and it went up, don't just try a different number. That's how you get not good at doing hydrology studies. Make sure you understand why it did what it did. And if you don't, then come get me and I'll help you figure it out. Occasionally, it doesn't do what it's supposed to do. And like we run some tests, this happened a few years ago, and it wasn't doing right. And I posted on a forum that the thing was jacked up, and then after I wrote, then everybody else started posting too that they noticed it was funny, and it turned out that a Windows update had like made it kind of buggy, and Autodesk had to come out with like a fix. So software is not perfect. If it's not doing what it seems like it should be doing, it could be that you're just not understanding it right, but it could also be that it's just wrong. But it might take a while before you're confident enough to say the software is wrong and your head is right. But it has been wrong. And last night it was doing that again, and I checked, and sure enough there was another fix that they had put out like a couple months ago. So make sure you understand, that it make sure it moved directionally the way you wanted it to, and that's just going to be one more instance of the way water works in a pond and through orifices that builds this model in your head of what happens in real life. And the more times you do it, the better you're going to be able to make intuitive decisions on where you want it to go. All right. Here's the second thing. A hole when there's we have a weir, we have holes, and we have weirs. When the water level is here, that area may be about the same as that area. When the water level goes up here, we have more head, so we're going to push out more water, but the area is the same. Here, our area is way bigger, and the head is higher too. So, on this guy, you're going to let out a lot more water at the higher storms than you are at the lower storms. You know, they might let out the same at the lower storms, and this one's going to let out a lot more at the higher storms. So if you want to let out more water down low, but you don't want to let out water up high, which thing do you want to have? Which one do you want to use?
Northwest.
Yeah. And that happens occasionally. You know, we could keep going up on this guy. Let's just do it. Let's say there's 3 of these guys, which we could do. You know, we could make a 6-foot diameter box and do 3 holes. You know, just be really expensive and not worth it. See, not much happened there. We may never get to the point, we still never got to the point where I let out more. But occasionally, on different systems, you'll get to the point where you might be letting out too much up high and not enough down low, and you want to make sure to really take advantage of those orifices, and as opposed to the weirs. The problem with this software is you only get 2 holes, and then after that you have to go to weirs. That's why I'm open to you guys learning storm and sanitary sewers, because I think it just has a lot more capability and functionality. But I have no interest or desire in learning it myself, so that's on you guys.
And why do we not try to change the size of the first?
Well, because we want to give them a freebie.
Water quality.
We want to give them a little water quality, just so that, I mean, we're only wasting, you know, 4/10 of a foot of a pond. It's not much. You know, it's less than 1,000 cubic feet.
So to increase the size of that first hole would be to reduce our water quality.
Well, it would just make it go out a lot faster. Which means, if the whole reason for making the hole small and leaving the water in there for 24 hours is that the particles can settle out, and then the water's cleaner and it goes out. If the water just comes in and it goes out, nothing ever settles out, and it's just as muddy looking when it came in as when it goes out. So it just doesn't do anything for water quality.
Okay, so the particles settle in the structure or in the surrounding.
Well, it'd have to settle in the structure, or in the detention facility, not the outlet structure. You know, wherever it's sitting, the particles are slowly just going to settle out.
Okay.
But it might take 24 hours, and it's still not going to be drinkable. You know, it's still going to be cloudy, but it's not going to. There's a lot of it will settle out.
Got it.
That's the only reason to have a small hole. Let's do that. So we'll go back. Well, now let's start pushing this guy down a lot lower. So if these 2 holes are at 3.6, 603.6, this is at 607. We have 10 inches in between. They're 1.2 inches tall. So the top is going to be about 604.8. So if we came down with a little weir down to 604.8, whenever you do a weir, it just assumes that it's empty into infinity. So let's lower this to 604.8, and I think that's probably going to be too big. Let's just make it 1/2 a foot and see what happens. And since that's a 1/2, this guy needs to be 3.5. Alright, let's just see what happens. I guarantee we're going to let out more water up high. Alright, so we're kind of where we are. So we still haven't gotten to that weir yet. Still haven't gotten to the weir. Still haven't gotten there. There, we barely started getting there. So really, we're only getting to the weir and the 100-year storm. And it's not enough head to push much out. So, let's go ahead and save this guy. Hydro V2 for, alright. Now, we are using less than 6,000 cubic feet. Our pond is 12,000. So, it can be half the size. The reason they call these guys 180s, that's the model number, SK180, because one unit with all the gravel and everything is about 180 cubic feet. So if we need about 6,000 divided by 180, that should be about 33. What if could we just do 2 or 3 rows? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we would need about 3 rows times 3 rows of 12. That gives us. So this length is 99. Yeah, good. I see you're using those things. 99 and a half. Alright. So let's go back in here. Let's save another one as V3. And we're going to keep that the same. We're going to keep that the same. Keep that the same. Barrel length is 99.5. We're going to do 3 barrels. Headers, yes. Stone encasement, yes. The bottom, we're going to do the same as that because there's not going to be any storage underneath of it. So we'll do 603.2. The width, wouldn't that be? I thought that was the total width. Let's see. 7.39 minus 6.5 is 0.89. Eight inches. 78 plus 8 divided by 12, 7.81. Did I do that? 78 plus 8 divided by 12, 7.16. So I think that should be 7.16. 7.16. And then the depth is 3.79 plus another foot on the top. So we'll call that 4.79. Alright, so now we're down to 6 to 8,000. 36 times 180. So that's a little bigger. I wonder if we have more stone than their standard thing. Oh no, we've been talking for an hour. This is getting ridiculous. Cut sheet. So 9 inches is their standard. And chamber volume of stone. And they have it 12 inches on top. Wonder why this is coming out bigger. let's do 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's why. One reason why. So there's 12 and 3. We'd lose a couple there. That's 85.3. 85.3. And if we're losing 2 units here, divided by 3 barrels, that's 2/3 of a unit on each barrel, right? And if each barrel is 7.1, 7.1 times 0.667, 4.8. So let's just take off another 4.8 feet off of this, which is 80.5. Alright, so now we're closer. Let's roll with that. And so basically what we're saying is we're not going to have these guys, and we're not going to have any of those guys, and we just have this. Is that fair?
Mm-hmm.
Does that make sense? Alright. So now we've got to start all over again. But we've already explained everything, so it shouldn't take as long this time. So that's about the same. It's actually a little bit higher because now that our pond is smaller, it's actually ponding up taller than wider. And we're getting more head, so we're letting more out. So that's kind of a good thing. So that's okay. That one's okay. That one's still okay. That one's still okay. That one's still okay. That one's okay. And that one's okay. So we could still make this weir a little wider. Let's try making this a foot and this overflow 3 feet. We're still less. We're still less everywhere. Alright, so let's I'm going to go back into I guess one thing to point out, we didn't really need to draw anything that detailed in order to put this in Hydrograph. We just needed to have kind of an idea of our cross section, and then either how many units or what general size, and then we just put that information in Hydrographs and we designed our thing. So you can do all of this stuff before you really draw it out. All you need is some just generic boxes to kind of pencil in your volumes or sizes. Does that make sense?
You need the area of it, right, to get to determine the volume.
Yeah, because especially the area, especially because you generally we're going to be doing infiltration, and so you're going to have, like in Georgia for an infiltration trench, they want this to be 3 feet. So in Georgia, a lot of times we make this 3 feet.
But it's 6 inches for this project.
Well, here it's 0. There's no storage volume at all. There's no infiltration there. It's just crush and run. It's just totally solid.
So we can't say that we're using an infiltration trench.
Correct,
or anything.
because there's nothing, they can't soak into the ground. So if we have 3 feet in Georgia times 0.4, that's 1.2 feet of water volume per unit foot. And then if we had, an area of 3,200 times that 1.2, we would have 3,800 cubic feet for runoff reduction. Well, when you do your stormwater strategy, you just type your numbers into the spreadsheet, and then it tells you what your runoff reduction number is. And then we just made a quick calculation right there, and if you're bigger or smaller. So really all you need is to know in your head what your cross section is, and then sketch out an area and multiply it together and see if you're good for your runoff reduction. Alright. I was going to get a detail. I'm going to go back. To this other project. It wasn't there. Oh, 110. There we go. this guy. And you don't have a 302 yet, do you?
No.
Let's make a
Water
302.
quality sheet.
Yeah, or just a stormwater BMP sheet, really. In this case, our BMP is not so much for water quality as it is for attenuation. We really want like a you know, a sheet for each BMP.
So a sheet for the detention and the sheet for the OCS.
Well, the OCS is part of your detention,
Okay.
so you could just throw it all together. But if we were doing infiltration and underground, you would do one for your infiltration and then one for your stormwater facility. Because in Georgia, they're considered two different things, one stacked on top of each other, but they consider them two different BMPs. All right, let's get rid of this junk. I guess we really don't need that either. Oh, I'm missing part of that guy. I exploded it to make changes. Alright, this one, where is your outlet control structure? You gonna do this guy?
Oh, I thought. Well, since there's a drop inlet above there, we were
No,
gonna do it
here.
Here, yeah.
Yeah. Oh, and then you get extra volume in this. We're not even counting that, but that's free volume. Alright, so we have an angle like that. Where was that sheet? I'll get rid of that guy. Oh, this one was a block. What I like to do, let's see if I did this here. I don't always do what I like to do. Yeah, 4 feet inside diameter. I like to draw all my stuff to actual scale so that if I want to go and modify it later, then it's easy to modify. I make that a block and then I shrink the block down to fit in the detail area that I want, and then I annotate it up. And so I want to make changes. Now it's nice because I can just double click into the block, its actual size. I'm going to get rid of that guy. I want this pipe to be rotated from the center. That was about the angle, wasn't it? Looks good to me. This guy, rotate him. Just make him kind of halfway in between. Was that half? I'm going to offset this again, 0.25. Make that closer to halfway. I'm not going to make that mistake again here. I'm going to go to somewhere short of halfway, and then I'll go again to the other point. And see, since I'm not crossing over the midpoint, it's going to keep the exact same curvature. Here I crossed over the midpoint, and that's why it popped that thing out. Okay, so that one, those are my holes. I don't know where my holes are yet. We'll have to redo that. Alright, here's this guy. We had two 15s, right? So at the bottom, we've got a circle that is 0.05. Let's make sure this is still 4 feet. Yep. Put him to the middle. This guy is 1.5. Oops. Diameter is 2. There we go. And these guys are diameter 1.25. And move the quadrant to the bottom, and then we'll move it up 4/10 or 5/10. 4/10.
4 sounds like a number.
2, 6, yeah, 4/10.
Sounds familiar.
All right, and then we have 2 of them. Let's give this 6 inches from the side, which is a 1/2 foot. Copy from this quadrant to there and to there. I'll just move this back 1 1/4.
No crew here.
Yeah, having a party.
Come back later.
Okay. All right, and then this guy down the middle, we were out to 1 foot, right? That was 7. Let's go down to.
You talking about the spacing?
Yeah, I'm gonna move these.
Or the weir.
Yeah, the weir. I'm gonna move these over another. Well, I'm gonna make them 4 1/4 foot, 3 inches from the wall to give us more space in the middle. Quarter, because I want to let out as much water as I can, and I'm not letting out enough right now. This guy, 0.5. Oops. I think that's a little too close. Oh, you know what? We haven't even measured the heights of these things yet. So if this bottom is 3.2, 3.27 minus 3.2 should be 3.8 tall, and we're 3.3, so we need to stretch it out another 1/2 foot. And now this is 2.5. We're not going to go that low. Now, another idea, since this really isn't giving us what we want anyways, what if we made this guy smaller, these 2 guys smaller, to give us more gap, and then we stretched this guy down and made him bigger? You think we'll let out more water?
For the, we'll let out more water for the 50 and 100-year storms. And then
It probably won't change much on the lower storms, because it didn't change much anyways when we went from 12 to 15. But we still just want to let more water out because we can. So let's try it. So this is the kind of things you need to know what happens when you change things around. And I didn't want to get too detailed until I started drawing this out, so I could see like how much room do I have to work with here. And you probably want to always keep at least 4 inches in between holes and things. That's probably pretty close on something big, but on something small, it's probably fine. So let's go back in here. Let's test our new theory out. We'll make these guys 12, and let's make this guy 1.5 feet. And let's see, if those things go to 604.6, but they're going to come over to here and there, so we could probably, let's try stretching that guy down. 4.6, let's see if we can get it down to 4.2. Alright, so in the 100-year storm, we're ponding up. It might have already run. Looks like it might have already run. Yeah, that did some calculations. So we're good. We're good. 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 We're still fine. Look how much smaller our pond is than before. Took it from 12,000 to 3,500. Now, usually you don't get to make your pond this small. The main reason is that this is all D-type soils, which is very impervious, and so this is working extremely in our favor, whereas Florida works extremely not in our favor. With the SES method, you have an initial abstraction that soaks into the ground, and then after that everything runs off. So on all these smaller storms, basically everything just soaks into the ground, but then after you develop or you just make it impervious, everything just runs off to begin with. So it's like you're shooting yourself in the foot because there's zero runoff in the beginning and then everything's running off in the end. Well, here in Alabama, at this part, the soils are really bad, so nothing soaks into the ground to begin with, and so when we change it to impervious, it's not that big of a change. Does that make sense?
Mm-hmm.
So we don't have to store that much for this project, whereas a lot of stuff in Florida, we have to store a lot. Now, if we're trying, that was a pretty big one. If we're trying to,
Flashbacks.
to what?
I had a tree fall in my house last year.
Oh, really?
Woke up and it's just like 200-year-old tree, just like caught, kind of. The neighbor's house caught it.
But is it in
like,
your house?
It was on the corner of our house, yeah.
But it wasn't in the room?
No.
I thought you were saying you woke up and there was a tree there.
Fortunately,
When we're doing infiltration, though, we always really like type A soils because then everything can infiltrate. So it's kind of a double-edged sword. Everything that we do is a double-edged sword, you know. If you do this, it's good, and the other thing, it's bad. So, but here, you know, it's not working out in our favor for runoff reduction. Thankfully, we don't have to do runoff reduction, and it is working out in our favor for stormwater. So I kind of like this. We're even smaller. We've almost cut it in half again, but we're going down to 604.2. So let's go back into this guy and see if that actually works. So 604.2. Well, that's 2 feet above the bottom, right? No, 603.2. That's 1 foot above the bottom. So let's just go up 1 foot and let's just measure to make sure this is right. 2.8 plus 2.8, 7. Yep, that's right. All right, 12 divided by 15 is 0.8. So I'm going to take this guy and I'm going to scale him from that point by 0.8 and scale this guy from the quadrant by 0.8. And I'm going to try to stretch this guy from there to there, and let's move these guys over from that quadrant to our 3-inch line, and put a 3-inch line over here, move him from there to there. Man, we could really go down further if we wanted to. I mean, we may not even need those at all. Like, what if we just did like one hole on one side and then a thing that went down? What's interesting sometimes is I've done ponds where all you have is an outflow pipe, and that's your entire control, and you basically just say you don't have any of this stuff, and that's the only thing, and you can kind of size that and get it to work. So there's a lot of different things you can do, but those types of things only work well in very low head ponds like this. If you had, you know, a 10-foot deep pond and all you had was an outflow pipe, you'd have tons of head pressure gushing it out that pipe, and that would never work. Alright, so we kind of like this. let's save it. And do we just want to try another one? We really don't need V2 at all, but I didn't want to delete that until we had a V3 that worked. So let's go back into this. Let's change this guy to 1, and let's take this sucker down to 3.6. Start at the bottom. Good. 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 Are we gonna make it?
Yes.
Probably.
Yep. We're still kind of at that same 53. Alright. Let's make this sucker wider. 2, 2. Is all this making sense? Still totally fine. Just for fun, let's turn these off and have just an outflow pipe. We're fine.
And that's because we're...
There's just not enough head to push it out the pipe. Yeah, when the water's this high, the orifice is only that big. When the water's this high, the orifice is that big, but it has so little head, it's just kind of like just falling out.
You turned off the... You left the weir on and turned off those... all the orifices? Or the two?
Yeah, I turned off everything except for the outflow pipe. Some outflow pipes there, everything else is turned off.
And that's just because we're... I mean, is it because we're reducing the impervious on the site?
Well, no, just there's not that much flowing out because there's not enough head pressure to push it out. But it's because the soil type is bad. That's the reason that we basically have a low requirement. Oh, those are his legs. Like we'd be nowhere close to meeting this if we were comparing against Type A soils, because Type A, everything's soaking into the ground in the beginning. Here, everything's just sheet flowing off. Well, the curve number was 77. I was like, yeah, it seems kind of wrong, but sure enough, woods with Type D is 77. I mean, some of our, not like a super dense, but like a residential neighborhood, the post-construction curve number might be 77. So that's like saying that this soil here is worse before anybody touched it, totally covered in woods, as this other development is after they built a whole neighborhood with houses and roads and everything. That's how bad the soil is. So now here's the question. If we don't put an outlet control orifice in there and just have our outflow pipe, does Gardendale get confused and think that we just don't know what we're doing? And they're like, you don't have an outlet control thing, you know. You need to have an outlet control structure when you do a pond. Well, normally you do. So that's where, you know, I start thinking, all right, it's going to take an hour to draw up this detail. We already have it in Hdyroflow. Do we just put it in there because it basically functions the same and not have to listen to, you know, some box checker tell us that we don't know what we're doing and trying to convince him that we do know what we're doing when it's way above his level of comprehension? Or do we just do this and just act like everything's normal? You know, it's going to be cheaper if they don't do anything, you know? So those are, you know, good decisions to think about. And if that's the outflow, we could really ellipse from the center that sucker a little wider. And let's put him coming in over here like this. And so that could be our inflow. And that's our outflow. I mean, we'd still want to label them. So which do y'all like better? The one hole or the 2 hole?
If you're trying to save money, probably go with just the outflow, just the pipe.
Yeah. Here's another idea. What if we just get rid of the holes altogether and we just do a wide hole weir here, and then we just lower this down to where they're just kind of building this little thing, a little weir. Let's try that. Let's turn these guys back on. We're not going to use that guy. Alright, we'll keep that the same. 3.6. Let's just lower this to 4.6. And then it looks like we have something, but it still is not much. Good, 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 good. Did I click all of them? That's pretty close. We're still at the same 35, so it kind of doesn't matter, but it's going to be more simple for them to make, and we just have that one little hole in the beginning, and then I like that because it looks like we're still doing something, but that's going to be pretty easy to do. This guy is 2 feet wide, right? Did we do 2 feet wide?
I catch that.
And the top is 1 foot up. Oh, I need to lower this down. That's 1. Lower this down 0.6. Oh, no, that was supposed to be to there, wasn't it? 0.4. I guess that could go over there. So that's really all we have now. That, and then just a gap. That's going to be pretty cheap and easy to do. Okay. We'll save V4 precipitation. You already have, you put this in, right?
Right.
Okay. And we'll just go to reports, skip that, never prints, looking good anyways. Actually, I had this idea. Let's just do, can we do just the summary pages? What if we do the summary pages, rainfall report, and return period recap? Print to PDF. Two, 1, 3, 1, 0. see what that looks like. All right, I'm gonna stop.